to finish off 4.4. You're talking about general solutions, and we've done general solutions already when we were talking about coterminal angles. It's the same idea. You can have an infinite number of answers because there's an infinite number of rotations. There are three ways you can identify when they're asking for a general solution, and so or three common ways, I guess. So one common way is if they say the domain is all real numbers in words, or if they can do the exact same thing in math notation, where x is a member of all real numbers or theta is a member of all real numbers, depending on whether they're using theta or x, or they could actually use the words general solution. So in either case, in any of those three examples, they're asking for a general solution. So for example number 2, A is not a general solution and B is a general solution. So you can see that as an example of asking for a general solution. So let's do A first and get our answers, and then we'll add the general solution to it. This is very much like a question that we did earlier. Cotan here is a reciprocal function. It's the reciprocal of tan. So I'll say that I'm going to find the reciprocal of the left-hand side, and then the reciprocal of the right-hand side is root 3. And now this is the exact question that we solved a little while ago. I remember this is a pattern, root 3 over 2 over 1 over 2, and tan is the sine over cos. So when is sine root 3 over 2 and cos equal to a half? This happens at pi over 3, so up over here, pi over 3. So the answer for this is theta is equal to pi over 3. Now, this is my reference angle, and it's in the first quadrant. It also happens to be my first answer because this is positive, and tan is positive in the first and in the third. So if it's positive in the first and the third, this reference angle here and here, my second one will be equal to pi plus my reference, because this is in quadrant 1 and this is in quadrant 3. So my answer will be pi plus pi over 3, which is 4 pi over 3. So I have two answers. I have pi, where this answer is, pi over 3 and 4 pi over 3. Oh, let's check my interval. Oh, I have to include a couple more here. It's not just over the first positive rotation, it's also in the negative rotation. So if I'm going in the negative direction, this would be 3 pi over 3 minus that pi over 3. So that would be minus 2 pi over 3. And then, did I get that right? That would be 3, so minus 2, and then also minus 4 pi over 3. There, I took a moment to make that a little bit neater, and then now it's minus 5 pi over 3. So here is my answer. And again, how we got that is we took our in a positive direction for one rotation, and then we thought in the negative direction for one rotation. Another way we could have done that is if we had the pi over 3 and the 4 pi over 3. We can think, oh, I can either add 2 pi or subtract 2 pi to find the ones that are coterminal. In this case, because if I added, I would go past my limit of 2 pi, but I could subtract 2 pi, which is the same thing as, in thirds, 6 pi over 3. So if I have 1 pi over 3 and I have to subtract 6, a coterminal one here is 5 pi over 3. And if if I subtract 6, I would get minus 2 pi over 3. And here are my 4 solutions. So one way I can do it is just sort of working out in the positive direction and then working out in the negative direction, or I can do it more systematically and take my 2 given solutions and either subtract or add 2 pi's as long as it's within the given interval. So those are my 4 answers. Now if I wanted to give my general solution, it's this idea. I take my pi over 3 and I say, just like we did with the coterminal, I can say plus any multiples of 2 pi multiplied by k, where k is an integer. And I can also go 4 pi over 3 plus 2 pi k, where k is an integer. And so that's a very good solution. You'll notice that in this case, it happens every once in a while that pi over 3 and 4 pi over 3 are actually pi apart. So I can state this a little bit more elegantly if I say it's the multiple of pi times k, where k is an integer. And this is another way to think about this, is that tan repeats every pi, so because these lines are straight across from each other. From here to here is a jump of pi, while for sine and for cos, right, if I was to do the same solution here for pi over 3 and I was thinking about cos, I'd have two solutions here, and they're not pi away from each other. They're not across from each other. So this is fine. You'll get your full marks, and this is just a little bit more elegant if you start noticing that these are exactly pi away from each other. All right, let's go on to the next page, the last page. Here we have tan of theta is equal to -4 over this interval. So this is not one of our special angles. I don't recognize this as being like a root 3 over 2 over 1 over 2, so you're going to have to use your calculator in this one, and you would say theta is equal to the inverse tan of -4. I'm going to consider now my reference angle to be the positive one, inverse tan of +4, and when I type that into my calculator, what do I get? I think I get 1 point theta r is going to be equal to 1.3258 in my calculator. So what does that look like? So my reference angle is in the first quadrant, somewhere over here. So here is my reference angle, and that is 1.3258 over there. I want to find out, though, when is tan negative? Tan's negative in the second quadrant and in the fourth quadrant. So this angle here is going to be the same as that angle and that angle. So my theta 1 will be pi minus my reference angle. So I think I get a value of 1.8158, and that's theta 1. And now I notice that my interval, I can go positive only up to there, and that's my positive direction. And in my negative direction, negative is so negative, so I'll use red for negative. So in my negative direction, I can go like this. And so that hits this spot in the negative direction. So I'll say theta 2 is equal to, well, this angle is the same thing as my reference angle, it's just in the negative direction. So I'll say negative 1.3258. And so there's my two answers here. I'll say this and this. Now, what about if the domain is all real numbers? I better go back to a more sane color. We'll go for green here. So I can say 1.8158 plus 2k pi, where k is a set of all the integers. And, well, I can actually use negative. That's fine. I can put down a negative 3.258 plus 2k pi, where k is a member of all integers. And again, just because both examples that we've done so far in general solution happen to involve tan, and because tan has this, being 1 pi away from each other, we could also more simply write 1.8158 plus k times pi, where k is a set of all integers. All right, so we have our last question here. Solve the cos of beta, and I don't know if this might be the first time we use this is the second letter of the Greek alphabet, beta, but it's the same thing as if you're using theta or x or anything like that, where cos of beta is equal to 0 in this example. So let's see, on our unit circle, cos is the x value. So when x is 0, I guess we can have up there or we can have down here. So in the first positive rotation, this would be pi over 2, and this would be 3 pi over 2. Okay, so we have pi over 2, and we have 3 pi over 2. And so I want to add or subtract 2 pi's. I can't add anymore and still stay within the 0 to 2 pi region, but I can subtract up until I get to negative 4 pi. Just a reminder, negative 4 is the same thing as negative 8 over 2. So I can keep on subtracting 2 pi's. So I can subtract 4 pi over 2. So this would give me negative 3 pi over 2. And I could subtract another one, and then I would get negative 7 pi over 2. Okay, starting with my 3 pi over 2, I can subtract 4 pi, and I'll get a negative, or 4 pi over 2, so I'll get negative pi over 2. If I subtract another, I'll get negative 5 pi over 2. And I don't think I could subtract another, oh, could I subtract another 4? No, because that would get me to negative 9, right? So these are my 6 answers. To go to the general solution now, I could say pi over 2 plus 2 pi k, where k is all the integers, and 3 pi over 2 plus 2 pi k, where k is part of all the set of integers. And we are done 4.4. Yay. And you have a little bit of homework to work on. Have a great weekend. We will see you soon.